All right, good afternoon, folks. Today we're going to be interested in covering all that you might expect to find under IGCSE, core and extended maths, algebra, and graphs. We're going to be looking at issues like substitution, proportionality, exponents, how we solve equations, be it linear, simultaneous, change of subject or formula. Sometimes when we plot graphs, quadratic, cubic, what's the behavior of the curve? Do we have increasing points, decreasing? That's where we might bring in concepts such as differentiation to find turning points of a curve. If it's cubic, we might be interested in telling whether the turning point is a maximum or minimum point. So without further ado, let's dive in. Right, so the first question that we have there, we are required to complete the statement. But now, if you look at the right-hand side, we are given an equation, x plus 3, the result will be 8. So if we solve that simultaneously, that linear equation, it will result in the actual value of x. In essence, we are saying if we transpose 3, we have x being equal to 8 minus 3, so our x is actually 5. Then we can write our 5 there. Moving on to the next one, we are given an equation which says 7y equal to 63. In other words, we are saying if we multiply 7 and y, the result is 63. Then, what if we multiply 10 and y? So before we do so, we can be interested in finding the actual value of y by dividing both sides by 7. That our y here is equal to 9. If I move to the second point where we have k, y being equal to, but we know the value of y, so when we have a constant value next to a variable, we refer to it as a coefficient, so it's a product. Such that when we simplify, it's 10 multiplied by the actual value of y, which is 9, so the result is going to be 90. So 10y is actually 90. These are basic questions, that's why they carry a single mark. Let's see what comes next. We are interested in factorizing completely. When you are factorizing, what's important is to look at the nature of the terms that we find within the expression. To say, here we have a coefficient and variables. Coefficient, so we might treat these terms independently. Say, let's deal with the coefficients themselves. 42 and 35, they have highest common factor of 7. So within these two, we can say we have 7 is our highest common factor. Then we move on to mk and m. The highest common factor there is going to be m. Then the next step will be building the brackets to say when we divide 42 mk by 7m, so we divide 42 by 7 to give us 6. Then m by m it cancels, so we end up having 6k. When we do the same to the next part where we start by putting the negative sign, 35 divided by 7 gives us 5, m divided by m it cancels, so that will be our final solution. Right, moving on. We're interested in simplifying these algebraic expressions. So from laws of exponents, when the base is the same and we are multiplying, we simply take the common base, which is n, then we sum the exponents. Now, if we check the second one, there's no exponent, and when the exponent is not given, it means it's a 1. So when we add 5 and 1, it will take us to n to the power 6. Moving on to the second one, similar approach, we start with the coefficients themselves. 8 divided by 2, it gives us a 4. But then, according to laws of exponents, when the bases are the same, for this case it's x and x, and we are dividing, then it's going to be the difference of the exponents. So we take the common base first, x, and if we say 6 minus 2, that will give us 4. I think that's our simplification there. Moving on, another with number 10, and this sequence is starting with -3, we move to 4, 11, 18. We're interested in finding the next term. Now, in order for us to pick the next term, we look at the behavior of the differences. In other words, if I look at the difference between these two consecutive terms, 4 minus 3, it gives me positive 7. If I say 11 minus 4, it gives me 7 again. 18 minus 11, it gives me 7. So it looks like the difference that we have there is always a 7. So if one, the next term, you add diagonally to say 18 plus 7, it means the next term within the sequence is going to be 25. Now, this explanation that I was giving, it tells us how we got our answer by looking at all the adjacent terms difference. If it's common, then we know that will be an arithmetic sequence where we just continuously add the common difference. So our explanation will be in the pattern we are always adding 7. Sorry, not 8, but we're starting with negative 3. Right, moving next, we are given an equation there with 4 variables, v, u, a, and t. Now, interested in finding the value of v when u is known as 30, a negative 2, t 7. So our calculation is going to be v equal to, because u is known as 30 plus our a is negative 2, a, so that's a product, so we're multiplying by 7. So when we simplify that 30, negative 2 times 7 gives us negative 14. And when we have positive and negative, it simplifies to a negative. So that's negative 14. And 30 minus 14, it simplifies to 16. Moving next, we are interested in expanding and simplifying again. But when we expand, it's like we look at the coefficient or the term before the brackets. It will multiply all the terms that we find inside the bracket. For instance, in this case, 2 is multiplying 3 plus w. In this case, 3 is multiplying 3 minus w. So our first step is to put an equal sign. So we say 2 times t gives us 2t, 2 times w gives us 2w, and on the next set, 3 times w it gives us plus 3w, and 3 times minus t gives us minus 3t. Now, the next step we want to try and check if we have like terms. Like terms are terms where the variable and its exponent or degree are the same. For instance, in this case, we have got t to the power 1 because we don't see the power there. Now, the last term again is t to the power 1 because the power is not highlighted. So what it means is those terms are like. So if we say 2t minus 3t gives us negative t, then the same rule applies to the other two remaining where the variable is w. 2w plus 3w, that will give us plus 5w. Think that will be our solution. Right, moving next, we want to factorize completely. We are given an expression 15v squared minus 3v. So in the similar approach that we did before, we look for the HCF of the coefficients, that's 15 and 3. So the HCF is actually 3. Then we have got v squared and v. The highest common factor there is actually v. Open our bracket. So we start the process where we're dividing the coefficients by our HCF. In other words, 15 divided by 3 to give us 5. Then we follow with the next, which is the variable v squared divided by v, it gives us v. Then we do the same for the second part. Negative 3 divided by 3 gives us negative 1, or we don't write the 1. V divided by v, actually, we'll be forced now to put a 1 because it's applying to both the coefficient and the variable itself. So that's the best simplification we can get for that problem. Right, moving next we have equations. And this is a linear equation, not much of a challenge. We just collect like terms together, or in other words, we put them in one side, and constants or unknown numbers the other side. Normally, it's advisable to put the constants to the right side of the equation. But at the same time, in the process, you need to check what's happening with your variable. Because when you look for the unknown, normally the unknown should have a positive sign. So in this regard, when we check, if we transpose 9 to the left, it will give us negative 9x, which is going to be bigger because the variable with x there already smaller than 9x. So I would prefer, or it will be wise to have our x as positive. So we will leave our 9x here, then 5x will be transposed and gives us a negative. All right.